Hey folks, this pre-calculus lesson is on perpendicular vectors. So let's go ahead and get started with this here. So we're going to let vector A and B be perpendicular. So here's vector A perpendicular to vector B, and then let vector BA right here be the vector that's between their terminal spots right here. Okay, so here's the ordered pair B1, B2, and A1, A2 right there. Okay, so we have a right triangle right here, and because we have a right triangle, we can use the Pythagorean theorem. Do you remember from geometry? This side squared plus this side squared equals this side squared, so that would get me this equation right there. Okay, so far so good, right? Okay, so let's go ahead and use our definition of the magnitude of a vector, which is our length, you guys. Remember the length of vector BA? The length of that is, by definition, is the square root of, you subtract your x's, so this x minus this x right here squared, plus this y minus this y squared. That's all that says right there. All right, so what I'm going to do is take both sides and get rid of this radical by squaring both sides. So that's going to get me right there. Okay, I just squared each side. Okay, then I'm going to FOIL this out and FOIL this out right here. Okay, hang in there. You'll see why I'm doing this in just a second here. All right, so I FOILed all that stuff out right there, and then I'm going to combine all the a squareds together and all the b squareds together. So, and then I had two quantities of the two a1b1s and two a2b2. So I pulled out the 2 out of both those, and I have a1. I pulled out the negative 2 out of both those, so it changed that to a plus. Okay, you guys with me right there? All right, and then I'm going to convince you, hopefully, that this equals my vector a squared and this equals my vector b squared, okay? Because my vector a squared, which is my magnitude of my vector a squared, do you remember that right here? Given this right triangle right here, remember here's the vector a right here, which and so this would be over a1 up a2, okay? And then so this guy squared would equal this squared plus this squared right there, and I do the same thing for that right there. So that's where this came from right here. A1 squared plus A2 squared is just the magnitude of vector A squared, okay? And then similarly, this is vector B squared. All right, so so there that is right there, okay? And then what we got about a minute ago using the Pythagorean theorem, we got these guys. So the difference of these two guys is this stuff right here. So the only way, and I know that these guys are perpendicular because I got it when they were perpendicular. I used the Pythagorean theorem right here. So the only way I know vectors are perpendicular is if this stuff here equals 0. Otherwise, they won't be perpendicular. Okay, they'll still be vectors that have a same initial point, but if this stuff is 0 right here, then that means that they're perpendicular right there. So we're going to be focusing on this stuff. It's going to be called the inner product right here. And so the expression is often used when speaking on vectors. It's called the inner product of vector A and vector B. Okay, so we're going to have a formula here for the inner product that's in a plane. So it goes like this. So if vector A and B are two vectors with those coordinates, then the inner product is just this, you guys. We just it's just that stuff we just did. A1 B1 plus A2 B2. Okay, so it's going to be this x coordinate plus this x coordinate, and then I'm sorry, times, and then this y plus this y coordinate times this y coordinate. You guys with me? So this one times this one plus this one times this one. That's going to be called the inner product. And if it equals 0, then these two vectors are perpendicular to each other because we did that Pythagorean theorem. All right, and so that's just often called the dot product right here. Okay, so the inner product is also called the dot product. I think I'm going to go with inner product, but I don't know. I might say dot product also, whatever. So remember, two vectors are perpendicular if and only if their inner product is equal to 0. So here we go. Let's try one. Find the inner product of each, given those or given those vectors having the terminal spots. So the vector x has the terminal spot 2, negative 5, and vector y is 4, 1. Vector z has a terminal spot 10, 4. So that just means it goes over 10, up 4. Okay, this goes over 2, down 5. So that's what this vector does. Okay, so we're going to multiply vector x with vector y, the inner product of that. Okay, so I'm going to multiply the x's together, multiply the y's together, and add them together. And if it equals 0, it's perpendicular. Here it equals 3, so these guys are not perpendicular. So the inner product is 3, but they're not perpendicular. Okay, this guy right here. So I'm going to multiply the x's and the y's and add them together. the x coordinates and the y coordinates, and I get 0 on this one, so that yes, this one is perpendicular, okay? And then y and z, so I'm going to, so 4 times 10 is 40, plus 1 times 4 is 4, so 40 plus 4 is 44, so that one is not perpendicular as well, okay? Alright, so the same thing goes with inner products in space, except we have a triplet, ordered triplet. So let vector A in space be the triplet A1, B1, or A2, A3, and vector B be B1, B2, B3. Okay, the inner product of vector A and B in space is just like it is in 2 dimensions, except it's here in 3 dimensions. Okay, so you multiply the x's together, the y's together, the z's together, and you add them up. Okay, so find the inner product of these 2 vectors in space, and are they perpendicular? So if it equals 0, then yes, they're perpendicular. So I'm going to multiply, so 8 times 2 is 16. Plus, I'm sorry, I should go this way. Negative 3 times 3 is negative 9. Plus negative 4 times 2 is negative 8. You add all those up and you get negative 1. Does that equal 0? No, so that's not perpendicular. Okay? Alright, so cross products of vectors in space. Sorry, I forgot that. I should have inserted that, and I got my lesson was done. So build, so I couldn't redo it. Anyway, so just right here should be a little caret up. So cross products in space is another vector that shoots straight up out of the plane, and it's perpendicular to 2 vectors at its initial point. All right, here's a picture right here. Okay, so if you have vector A over here and vector B over here, and they're not necessarily perpendicular, although they look like they are here, but they're not necessarily, but the cross product is perpendicular to this vector, and it's perpendicular to this vector at the initial spot right there. It goes up straight up perpendicularly outside the plane right there. And right here is how we represent the cross product, vector A times vector B. All right, so the cross product is written just like that. So here we go, cross product of vectors in space. If you have the ordered triplet A1, A2, A3, B1, B2, B3, then the cross product of A and B is defined as follows. So the cross product of A and B. Now check this out right here. This is just a 2 by 2 matrix. Remember, a matrix we do this times this minus this times this. I'll remind you in just a second. Okay. Notice the A1 and B1. The first coordinates are missing in the first one. Notice the second coordinates are missing in the second one. It goes from A1 to A3. Notice the third coordinates are missing in the third one. That's how I remember it, you guys. And remember, this is just my unit vectors in space. This has ordered pairs 1, 0, 0. This has ordered pairs 0, 1, 0. And the unit vector K has the ordered, the ordered triplet, the ordered triple 0, 0, 1. Okay, so I think I have that written down coming up. So recall, yeah, here we go. So the unit vector I has the ordered triplets 1, 0, 0, J is 0, 1, 0, and K is 0, 0, 1. Okay? All right, and then so here we go. Find the cross product of vector V and vector W. If V is the ordered triplet 0, 3, 1 and W is the ordered triplet 0, 1, 2, and verify that the resulting vectors is perpendicular to V and W. So what I'm going to do is get the cross product first, and then I'm going to do the inner product with vector V and vector W to make sure they're 0. Okay, you'll see. All right, so this is just the rule right there, okay? So, and this is my A1 right here, A2, A3. This is my B1, B2, B3. How I remember is the first one is my first A1 and B1 are missing. So it's going to be 3, 3, 1, and then 1, 2. Okay, and then the second one, the middle term is going to be missing. So it's going to be 0, 1, and then 0, 2. Can you see that right here? 0, 1, 0, 2. And then this third one right here, the third number is going to be missing. So it's going to be 0, 3, 0, 1. So there it is right there. Okay, so now I'm going to multiply. 3 times 2 is 6, minus 1 times 1 is 1. So 6 minus 1 is 5. Okay, so that's where I get 5 times the unit vector I. And then here, 0 minus 0 is 0j, and then here 0 minus 0 is 0k. Okay, so 0 times anything is 0, so that just simplifies to 5 times the vector I, the unit vector I, and the unit vector I is 1, 0, 0. So we get 5, 0, 0 when I multiply that. Okay, so that is the cross product of vectors v and vector w is 5, 0, 0. That's the unit vector right there. Okay, I teach AP statistics, so I just got an AP email about upcoming events. So to verify this to verify that the resulting vectors are perpendicular to the vectors v and w, the cross product anyways, you check to see that the inner product is 0. So since this is my cross product result, I'm going to get the verify that this equals 0 and verify that this equals 0. And if it equals 0, then they're perpendicular. Okay, so remember cross product, so this times this plus this times this plus this times this. That's what this says right here. It gets me 0. Over here I get 0, so they both equal 0. So since the inner products are 0, then the cross products of the vectors v and w is perpendicular to both v and w. All right, well that's it, you guys. That's how you do this stuff. So if you are in my pre-calculus class, I would assign that as your homework. Take care, you guys.